ladies and gentlemen. My name is Karel Hendrych. I've been working for Juniper Networks as systems engineer, mainly focusing on security. So I'm the guy dealing with the firewalls, VPNs, network access control, SP grade things, TGN, EP, and things like this. And today I would like to discuss some new thing in our portfolio. It's called Junos Video Secure. It's a product targeting the DDOS attack landscape, and the agenda is as follows. So I still do believe that firewall is a fundamental part of DDoS solution and prevention. Then I would like to drill down a little bit into this DDoS security thingy, and last but not least, I have some few slides about management and manageability of those things. So to put it into some sort of context, in essence, what can be seen is consolidation in data centers. So if you have some apps down there that are fronted by some security equipment, nowadays the trend is to consolidate the things. So the firewalls are getting bigger, some refrigerator class of equipment, consolidating tens of firewalls, holding millions of sessions, setting up thousands of new connections per second, and so on and so on. It's good, it's excellent from perspective of, let's say, manageability, a centralized point, and so on. But the caveat, the con of this one is that you are putting your stakes on one box or a pair of boxes. If something goes wrong with this data center firewall, some equipment which is fronting the valuable assets, then you are lost, you are gone. It's good on one side. On the other side, it's also that the right approach, and that's my belief, is to consolidate and also distribute a little bit. So if you want to have some visibility down there, to be more, let's say, granular than solutions that are close to the internet, you have to have something down there. So it's, from my perspective, some mixture of technologies, shielding the apps in terms of firewalling, DDoS protection, IDS, and so on. So in terms of Juniper high-end security data center firewalls, there is a series called SRX high-end, starting with a box called SRX 1400, and it goes up to SRX 5800. I think it's a late afternoon, so I don't want to bother you with, I don't know, millions of sessions, some parameters you can check out from data sheets. That's not the point of this presentation. The only few takeaways I'd like to discuss is how the stuff is designed from some high-level perspective. So first of all, for our high-end firewalls, we took over the same architecture like for high-end routers. So we have clear separation of control plane and data plane, meaning that the control plane is not involved at all in processing of transit traffic. So whenever your firewall is under some heavy stress, facing some flooding attacks, some session table attacks, whatever, you can still log on to the box because the control plane is separate computer, and you can check out what's going on in there. Another attribute of our high-end security platform is the scalability. It's almost linearly scalable, meaning if you have, for example, one 10G interface, then with one processing card you have performance X. If you insert another card, you get almost double the X. It's not completely linear, it's almost linear. So what we are doing inside the box is automated load balancing of the services. So it's either VPN, deprecated translation, regular firewall, the flow firewall, and so on. It's automatically balanced. But looking a little bit deeper into architecture of the box, so from perspective of DDoS and DDoS prevention, what you can do are the following things. So the first component in the hand firewall is so-called input-output card. this permits you to install stateless policies. So this one permits you to do the variate policing of traffic. The next component is network processor. This one has the stateless screens. So this would be the ICMP, DNS, TCP flooding attack detection and prevention. So imagine if there is a flood like 3 million packets per second hitting some resource, this guy can stop those attacks up to, let's say, 4.5 million packets per second. And also, you can aggregate the network processors, so you are doubling the performance using link aggregation and things like this. And then the stateful logic, for example, dealing with screens like maximum sessions per source, maximum session per destination, things like single keys are being generated in social service processing units. So this is some high-level view on SRX high-end distributed architecture. There is no control plane involved in this one at all. No control plane. It's sitting aside of all those things. All right. To step out of some boring things. This was taken from some XIA tester. It was SRX 1400, so the smallest SRX box. And the use case was to have some legitimate traffic running, represented by some HTTP transactions, at some reasonable rate, like 1.6 gigabit per second among HTTP transactions. And besides that one, the box was hit by some UDP flooding. So you can see that there is something like 2 million packets per second aggregated hitting the northbound interfaces. The southbounds are being cleaned, and just the regular traffic is passing through. And the box is still open. There's no troubles because the distributed architecture stopped that flooding on the network processor level, and the service processing unit dedicated to the stateful processing had a lot of horsepower to process the IPS service. So this is some quick demo. All right, let's drill down into the Junos DDOS secure product. First slide is about putting it into some sort of context. So where would we place the DDoS secure product? There are a couple of options. The golden rule says as close to the internet as you can. So that would be a layer 2 transparent appliance sitting between the core switching equipment and some upstream routers. Or you could place that equipment as a virtual appliance. This is the granularity I was speaking about. So, for example, having some screening DDoS secure appliances upstreams, dealing with some, let's say, generic attacks, and some customer-specific appliances down there in the VMware installs. So, what is DDoS secure about, and what does it protect? It protects servers, so it's protecting weak IP stacks, bugs. It has basically the stateful logic inside, so it's also a stateful firewall. To a certain extent, you could even configure this solution to act as a firewall, but as this one is acting as a true transparent device, you can do things like network address translation and so on. It's protecting stack table resources, so all the time it's keeping an eye on the backlog of the service. So if there are many connections in the synapse state, the DDoS secure can recognize that the server is with some huge backlog and can take some actions. It's about protecting firewalls, load balancer, concentrators. So imagine if you have a load balancer in front of some server farm, and the server farm is running out of resources, so all the balance resources are backlogged. It can recognize and it can slow down the incoming traffic. And also, it counts for session overloads. Let's say the resource it's about gateway protection in terms of bandwidth and packet overloads. So imagine if you have 1G pipe to the outside and some 500 meg pipe to some practical resources. It can detect that some practical requests are triggering huge bandwidth saturation, and this particular attackers can be put into background. So it's about the BPS, megabit per second, GPS protection, and also BPS. Each and every resource has its definite number of packets per second it can deal with. And another resource is URL. URL is based on coding of HTTP protocol, and each and every query sent to the backend server is being treated as a resource. So if there is some static content, then most likely it's going to respond fast all the time. If there is some dynamic content which is triggering some huge lookups in the database, in some backend database, then that one is different resource. It may respond slower or faster. It depends how the backend is doing. So, in essence, the DDoS secure machine is sort of a filter or sort of web machine. So the legitimate traffic is coming into the box. It's hitting the resource, and if that one is mixed with the DDoS attack, then the DDoS traffic is being blackwalled, is being dropped, and the legitimate traffic is leaving that attack. So, how does it work? The guys who designed this solution designed it from the beginning as let's say high-tech, low-touch. So they started really by using some couple of boxes on the tables, and then they were investigating various types of attacks, and that was back to year 2000. And then I think 2001, 2000, they sold their very first solution to some bank. Interestingly enough, it was a bank in Greece. And what they invented is a mechanism, heuristic mechanism, and the score each and every accessing client is getting is called charm. So it's a so-called charm algorithm. So what it means? It means that if I'm human, behaving like a human, so I'm opening up URL, it loads for 5 seconds, then I'm clicking some particular link, then I'm having some coffee, eating some cookies, then I'm behaving like a human according to the timing, how the web is interacting with me. I may get on a scale from 0 to 100 score like 70 for humanistic behavior. If there is some first-time traffic, then it's always with a question mark. It may get, let's say, 40, 50. And if there is any mechanistic traffic, like some bot is scraping the website, like doing hit, opening in a loop in a circle, some pages, it may get some bad score, like 30, 20, it depends. As I said, it's behaving as a firewall, so the first thing happens is that it's validating the packets according to IRC filters, conformance with IRCs, all the mis-sequenced out-of-site packets are being dropped, and I mean, there is no point in passing two packets which are out of sequence. They may be dropped elsewhere on a firewall, and so on. So, then if we have particle scores for each and every accessing client, then charm algorithm is looking into charm threshold. Each and every resource, meaning each and every TCP port, HTTP URL, SIP resource, DNS server has individual charm threshold depending on the server responsiveness. So if the server is doing good, you may get a response in, I don't know, hundreds of microseconds. If the server or something on the backend is somehow struggling, the response times are increasing. So it's not going to be anymore microseconds, it might be tens of milliseconds, half a second, couple of seconds. So it's about detecting how the backend is doing. Based on how the backend is doing, is the charm threshold being increased for each and every resource. Meaning that if the humans are classified with score like 70, machines with 30, 40, and the charm threshold goes up to 40, then those machines are going to be filtered out and just the humans will be left through. It's changing dynamically, meaning that within a couple of seconds the charm threshold may change based on detection if the resource is under stress or not. The nice thing about that one is that there are no server agents. It's entirely based on passive analysis on backend responsiveness. It's also good in terms of if you are protecting some load balancers, then if you are adding more servers to the balance pool, then you are getting more horsepower, then you want to drop the charm threshold because the backends are doing good. If you are removing something from the balance pool, then the charm threshold may need to go up because the backends are not up. Right. So just to recap, how does it work? Let's say this packet has potential to make it to the end. So the packet is entering, the packet is being validated by the syntax screener. If everything is well according to RFCs, the packet is validated, again sequencing, if the connection is in state, and so on. If not, the packet is being killed. Then charm value is being calculated for each and every packet. That one is referencing so-called IP behavior table, which holds up to 64 million resources. That's info about all the accessing clients which are accessing the backend resources. If everything is fine, the charm value is calculated and the behavior is recorded. So each and every machine has its own record in the behavior table. It may change over the time, so if someone is behaving well, so behaving like a human, then out of sudden that client starts to do some strange things like scrape the site, repeat the request, starts to behave like a bot, then the behavioral table is updated according to that one, and the charm score is being lowered. Then according to the access resource, the charm threshold is being considered. So there may be some particular URL serving some static content with some low charm threshold, that resource is doing good. There might be some dynamic content which is somehow struggling. The backend database is under stress, and such a resource might be with some high charm score. So the packet may be dropped or passed, depending on the resource. There's one mind-changing thing about this one, that it works even a different way around. So it's not just about protecting from outside to inside, it's also about protecting from, let's say, inside to outside. So if some servers are, after some sort of security breach, part of some botnets, then this solution may prevent them to flood outside the internet, outside world, by some, I don't know, HTTP requests, SYN floods, and so on. So it works also other way around. Okay, what's the difference between DDoS secure and signature-based blocking? We do not have any signatures on the box, so it's completely without any signatures. It's based on behavior, but it's important to notice that there is no profiling. So you don't have to profile the site like during peak periods. You profile during summertime and so on. There is no need to configure anything manually. It comes with automatic threshold configuration, so it detects how the backend is doing all the time. So the idea is to have behavioral learning and minimal configuration. There's another mind-changing thing inside. It only drops if the backend is struggling. So as long as the application is well designed, well scaled, it won't anything during work operation. Only if the backend app or generic PCB UDP application is struggling, then it's dropping the packets. So it's a way how to prevent any false positives. If you are seeing any false positives, there are ways how to fine-tune it. For example, let's assume you are protecting some bank application, some banking front end, and I would guess that majority of customers are coming, for example, from Poland. So the thing you can do is to say, okay, if the client is coming from Poland, let's increase artificially his charm score by 10. So you are prioritizing rather folks coming from the local country rather than guys coming from China. Yeah. This one is particularly important. Imagine a couple of years ago the slow loris attack popped up. It was very easy to bring down any Apache server within a couple of seconds. This was the slow and low attack. This is something which is DDOS primarily targeting, the slow and low things. So few packets bring the site down. Let's say the volumetric solutions that are detecting some peaks in the flow using NetFlow, some sensors and things like this are blind to those kind of attacks. But if the DDoS sector is seeing that the backend is struggling, that out of sudden it's completely backlogged, all the sockets are wasted, it's not responding to new same packets incoming, then it's starting to enforce the traffic. And the slow loris is being detected within I think 1.5 seconds after someone tries to use this tool. It's quite plug and play, low maintenance without human intervention. As I said, it's a layer 2 transparent device, so you can bump it into wire. It's coming with the learning mode switch on. It doesn't enforce unless you switch it to the enforce mode. There are some capabilities for this plug and play functionality, because usually when there is some DDoS attack going on, the customers are screaming and they're inviting various vendors to place that equipment. So if you pump it into wire, it's learning the state, for example, the state of TCP connections for a while, for 5 minutes, and then it switches on the stateful inspection enforcement and starts to enforce if you say so. Okay, so the DDoS secure is coming basically in two variants. The first one is physical appliance, which is the second one is physical appliance, which is basically one unit appliance able to deal with 2 million packets per second, something like 700K connection per second, and a VMware instance dealing with 700K and 800K PPS. You can scale this up. It's feasible to have multiple appliances, like 4, 6, and use LACP to run the traffic. As long as the LACP is using some symmetric hashing algorithms based on exclusive OR, etc., then the connections are kept in a symmetric way across the appliances, and there is no need to synchronize any states. With one exception, and that's fragmented traffic that might be missing. Physical appliances are equipped with fail-safe card, so there is either copper 1G, 10G fail-safe card, or 10G long-range short something goes wrong with the box, the power is going down, the failsafe card is kicking in, and it's behaving like a pair. It counts also for some events like if you are upgrading appliance, restarting the services. It's just behaving like a wire, so there is no traffic interruption. If you have a HA pair, so two of them, then if one is failing, the other one is taking over and enabling the bypass. So in the case of some corner case, like even the second appliance gets lost, the failsafe card is behaving like a bear. Okay, as I said, you can go either standalone or active standby pair or active-active. This active-active is intended also for the asymmetric routing scenarios. So the world is not perfect, internet is pretty asymmetric. So if the packets are entering one connection, leaving the other two DDOS appliances are syncing their state, so that they know that okay, the synapse is permitted to go to this appliance. It also counts for services like DNS. If you are looking into protection of DNS service, then this one is also covering that one. So, for example, the responses are permitted only if previous queries were seen. Otherwise, it might be some sort of DNS amplification attack, and so on. Just to elaborate a little bit on this one, we are understanding the DNS besides HTTP, SIP, and generic TCP, UDP. We are understanding also DNS. So, for example, if the service responding with a server fail message, it's being reported back to char. So the clients causing server to respond server fail are getting some lower scores. And also if some repeated queries are being seen, like someone is asking in a loop for one particular query, then this is indeed some sort of attack, some attempt to waste resources. Because caching servers are supposed to honor the PDL attributes of the DNS packets. Okay, so speaking about this one, some more details. There are two interfaces which are dealing with internet, and inside there is a third interface dealing with management, and fourth interface on the box, which is intended for the sync between appliances. It's designed to be low touch, even if we are running multiple appliances, they are synchronizing their configurations. So there's no need to log on to one box and to the other to reconfigure something. It's quite seamless. Okay, you may ask what to do if someone is flooding the upstream connectivity. There's nothing you can do besides signaling upstream. Currently, what we do support on the JDOS appliance is remote trigger black hole. Something which we might look sooner or later into is BGP flow spec. So that's work in progress. All right, how to manage all the things. So in terms of SRX management, there is quite addictive Juno CLI. There is a new management platform called Juno Space. There's an excellent application for managing security policies called Security Director. In terms of GDUS, you can use excellent web interface plus command line. And for logging tasks, there is something called STRM. STRM stands for Security Threat Response Manager. It's our center log collector and flow collector. There's going to be one slide more about that. We are Juniper, so we are quite open guys. So, for example, all the Junos devices can be configured using DMI netconf, which is IPF standard. And you are using XML for configuring that equipment. All the Junos devices can be scripted, so in case of seeing some events, you can change the configuration, you can react during some particular time, like to switch the configuration during midnight, you can do some syntax checks, and so on. There's very rich SNM email, so all the stats you can imagine can be pulled from the device, and all the equipment, JDOS, the Junos equipment, SDR, support the system logging. So the idea is to have some sort of centralized log collector receiving information from all the equipment. I was speaking about SDRM. It's basically our CM system. So this is the central point for logging of screening logs, firewall logs, JDOS logs, and based on internal correlation, you may trigger some high-level events. So to put it back into some context, let's imagine that there is some high-end SRX device, one JDOS appliance fronting the SRX device, DDOS appliances, virtual DDOS appliances for some customer-specific applications, and there is SDR console, so some center console, center point of visibility for administrators, with collectors for logs and flows. So if there is some DDoS attack going on and it's some sort of volumetric attack, then SRX may trigger some screening log, like some UDP flood is going on, some TCP flood is going on, and you may get that info to the log collector. Then the web screen may start alerting, hey, there is a high TPS rate to this particular destination, and the particular resource is struggling. So obviously going into some backlog that is not responding at all. So all the things are being gathered on the log collectors. Then there are some corresponding flow info and flow data being collected on the upstream routers, and that's being sent to the flow collector. And then the complex view about the flows and logs can be seen on the console, and console can trigger either using some admin intervention or in an automatic way some thread, syslog, script, and other things. So it might be used for signaling upstreams. So based on what's going on down there or on the hand devices, we may trigger some events, actions to the upstream. From some long-term perspective, there's going to be more inbuilt logic like this full stack things and so on. All right, questions? Yeah, the second one. Sorry?
Who's first? No, I've
You.
got one question. You said that you start logging after you see the backend server starts struggling.
Yes.
Okay, today we have cloudification and cloud bursting very often, and if the orchestrators see that you have too high CPU utilization on the backend servers, it start adding resources. And how do you cope with this? So you can, if the environment is in the cloud, the orchestrator can start cannibalizing the hardware resources by adding new hardware servers to the service. And I see, you say that you will not react to this.
Actually, if orchestrator will bring up some new VMs, some new computation pool resources, then we'll be seeing that the health of the resources is improving, and we won't be blocking anymore. It's gonna react dynamically on how the resource pool is doing. Actually, they are not fixing some underdimensioned or broken applications. They are fixing the state when someone is attacking the things. This might be some sort of side effect. So if something's struggling, you'll be prioritizing the current humans coming into the systems. If the computation pool is back online, there is not going to be any struggle anymore. Does it respond?
Yeah, so will consume all the hardware resources by automatic routing, and there will be no reaction.
You mean could you elaborate a little bit on this?
Yes, of course. So, for example, the orchestrator, the cloud orchestrator, will see the average CPU ratio is 70%, and it will start automatically adding the new hardware servers and deploying the VMs on it, and on and on and on.
Yeah.
And then still response time will be below, let's say, 100 milliseconds on HTTP requests.
I mean, this additional computation power has to be definite somehow, so it has to stop somewhere.
Yeah, but then it's too late.
And another thing is that we'll be dropping some illegitimate traffic, some mechanistic traffic on the DDOS. So the ultimate goal is to reduce the load of the backends when under attack.
Orchestrator, for example, spawns additional server. Responsiveness, gets better.
Yeah.
So the system reacts and kills additional attempts and so on.
If responsiveness is going to be the charm threshold for the resources is going to be lowered, and even some mechanistic traffic may be passed through. But this is about preventing false positives, because sort of mechanistic traffic is even Googlebot, right? It's going through the site, scraping, being quite aggressive. And I don't know permit is that. There was one more question, gentlemen. First now.
I have just one question about delays. Do you have some kind of delays when the box is not performing?
Yeah, from top of my head, there is something like 1 millisecond due to the heuristic processing. So it might sound like quite a lot, but it's a penalty for the heuristic approach. There's a lot of magic going on under the hood.
Do we have some kind of threshold? If the 1 millisecond is being broken, we can move ourselves.
Yeah.
And
So,
use the card instead?
so if you are, this would happen in case of some volumetric attack. So if you start to hit the box with some multiple billion packets per second, the box is not able to cope with it. And that's the point when we have to somehow integrate with some volumetric prevention system. So the pretty basis volumetric prevention is the firewall, the screening capabilities of the firewall device. If that one is filling in the pipes, then the firewall is useless and we have to speak with customers. So this one is complementary to any volumetric